Hello, I'm Ken Adams. I'm a professor at DRI, Desert Research Institute. I study geology and more specifically quaternary geology of the Great Basin. So in this short video I just want to talk about some of the characteristics that you might see on a classic sort of stair-step stack of shorelines in the Great Basin. This one happens to be composed of mostly basalt clast, and we'll get to that. But first, where are we? We are in Warner Valley on the southeast side. There's some really nice shorelines here. I don't know much about them because just driving through, thought I'd stop because they look pretty cool. And you see this type of shoreline stack all over the Great Basin, and if there were large lakes on Mars, for instance, you might expect to see the same kind of features. So this is this stack of shorelines is erosional in the sense that they look like a sort of a staircase, as opposed to constructional shorelines which are spits and barriers, tombolos, and that sort of thing. But these things are also kind of constructional. They're both erosional and constructional, and I'll show you what I mean here. There's my two dogs, Indy and Lucy. They're kind of tired. They've been in the field for a few days playing. And so we're looking down the tread of one of these things, parallel to it along contour, and it's kind of subtle when you're standing here, but when you're looking at it from a couple miles away with the right lighting, they just look spectacular, and it's really easy to measure their elevation and so forth. But as you notice, it's not really a stair. It's more of a slope, and then a steeper slope, and then a gentler slope, and then a steeper slope. And so the shoreline angle that people would commonly measure is represented by this slope break from the tread of this particular shoreline that we are standing on, and the angle between that and the riser where it gets steeper. And so where exactly would you pick this out on the ground? It's not obvious. There's probably almost always colluvium coming down this slope here and depositing a colluvial wedge at that shoreline angle. And so it's not as easy as it looks to get consistent elevations on these features if you were interested in that sort of thing. And so some people have used mathematical sort of models to estimate what the elevation of that shoreline angle is. I prefer just to survey if I needed to. And so there's also this tread that we're standing on. There's probably a wedge of sediment that extends out towards the lake, and right where we're standing near the shoreline angle, I imagine that the beach sediment, colluvial sediment, reworked everything by the waves, is thinner than it is down here at the crest of the rollover when it goes to the riser to the next shoreline down. And so these shorelines are composed of there are pretty coarse boulders, cobbles of basalt. Here's some nice ones here. And there's one 5 meters away that's probably up to a meter. But I doubt that all of these were perhaps moved by the waves. There's some bluffs right above us with some big boulders, and that may be an eagle flying by. And those could just roll down this slope and occupy these, land on these shorelines, on the treads in particular, and maybe the waves are just able to move sediment around them. So let's talk about the wave energy a little bit that's possible in this type of basin. So it's probably 10 or 12 kilometers across this valley, and so that's about the type of fetch. It's sort of Lake Tahoe in scale. And so waves on this planet might be up to, theoretically, 2 to 3 meters with 5 or 6 second wave periods. Pretty high energy, and those sorts of waves might be able to move boulders up to 30, 40 centimeters or so. And so it's not out of the question that a lot of these cobbles, boulders, etc. were moved by waves. Some of the evidence for that is the rounding that we might see. And when you're looking at these deposits, A lot of the larger class are fairly angular, subangular. Some are rounded a little bit. You see this rounding on this guy. And there's a lot of pebbles in here and sand as well. And it's sometimes more efficient or it's just more representative to look for rounding on the smaller class, because those are the guys that are going to be moving more frequently with various amounts of wave energy as it's coming into the shore. And so I try to, when I'm looking for rounding, I'm looking at the smaller class a lot too, not just the big ones that attract your eye, like this guy, this one, enough to convince you that there is in fact rounding, and this is a shoreline, although I don't really need convincing of that because it looks like a shoreline, acts like a shoreline, all those things. So again, you know, these kinds of shorelines are pretty obvious on aerial imagery. They're pretty obvious when you're looking at them from far away, but when you're up close on them, they're a lot more subtle. And I would suspect that the morphology, if there were in fact large lakes on Mars and a northern ocean, the morphology should be about similar, because those shorelines in the crater lakes of Mars, some of those were essentially closed basin lakes where water levels would be fluctuating according to the hydrologic balance of their basins, and there should have been enough wave energy to form shorelines on Mars as well.